What does true decentralization actually look like? In crypto, where it feels like power often ends up with just a few players. And how are some projects trying to genuinely open it up, make it more accessible, maybe take it away from the big tech companies and put it in the hands of, well, everyone? Today, we're doing a deep dive into the Pi node. We're pulling insights straight from Pi node, a leap towards decentralization, and some other related sources we've looked at.
Right. And our goal today really is to dig into the key details of how Pre-Network is tackling this. They're a pretty unique model for decentralization, especially focusing on how their nodes work. We want to explore why it's different, what it might mean for, the average person, and maybe touch on some of the hurdles a project like this has to overcome.
Okay, let's unpack this right from the start then. The big question, I guess, is just what is a Pi node? And how does it actually fit into this whole mobile-first thing they've got going on?
Well, looking at the sources, the Pi node is basically positioned as the fourth main role within the Pi ecosystem. So unlike the mobile miners using their phones, Pi nodes are meant to run on personal computers. Think, your laptop or your desktop at home. Their main job, like nodes in other blockchains, is verifying transactions on the ledger and critically reaching consensus about the order of those transactions. But here's where it gets really interesting, the core difference in Pi's approach to consensus. It's not like Bitcoin or Ethereum with their proof-of-work systems, the ones that use massive amounts of energy for those complex puzzles. Pi nodes use a modified version of the Stellar Consensus Protocol, or SCP.
SCP, okay.
And that's a fundamental shift.
Yeah.
It aims for, well, much lower energy use
Yeah.
and potentially faster transaction finality.
How does that work then, the SCP in Pi's context?
So the basic idea in SCP is that nodes define their quorum slices. These are essentially small groups of other nodes that they personally trust to validate things. A node only accepts a transaction if its whole quorum slice agrees. Now, the clever part and the challenge is how these individual trust groups bubble up to form a global consensus. And Pi's spin on this is linking these quorum slices directly to the security circles that the mobile miners build.
Ah, okay. So the people you add on the mobile app, that actually influences the node network.
Exactly. The trust you establish on your phone, inviting people that directly informs which nodes get to validate transactions. It's like turning your social graph into a cryptographic trust layer for the blockchain.
That definitely sounds user-friendly. The sources really hammer home this user-centric design idea, making it accessible for ordinary people, not just tech wizards. Just install an app, run it when you want. But doesn't that create a tension between, ease of use and the robustness you need for a blockchain?
That's a really good point.
Like, if it's too easy, could less savvy users accidentally mess things up? Or what about attacks if those security circles aren't as secure as people think?
Yeah, that's a classic challenge for any project aiming for mass adoption, absolutely. And Pi's answer, based on the sources, seems to be this layered approach to participation, plus a specific selection process for the nodes doing the heavy lifting. They're trying to walk that line, make it accessible, but keep the core network secure and reliable. It's about getting lots of people involved, but making sure the foundation is solid.
That layered idea, it feels pretty smart, not just about access, but maybe tackling that free rider issue you see in decentralized networks, where some people contribute a lot, others not so much. Here you've got different levels of commitment, right? From casual users to these dedicated supernodes.
That's a great way to look at it, yeah.
How does that balance the ideal of everyone joins in with the practical need for reliability? It almost sounds like different subscription tiers for decentralization.
It kind of does, doesn't it? The sources lay out three main ways people can participate with the Pi node software on their computers. First up, there's just the desktop app level. This is super basic. It lets you use the Pi app on your computer like you would on your phone, check your balance, use the chat, look at content. Minimal impact on your computer's resources for this one.
Okay, so that's level one, just using the interface.
Right. Then you have the node level. Now, these users go a step further. They access the node interface, do the technical setup stuff, and basically volunteer their device to run the actual blockchain component if they get selected. These are the nodes validating the blockchain, submitting transactions. And the vision is for them to eventually contribute resources too, like computing power, storage, bandwidth.
Right, doing the actual blockchain work. And the third level.
That's the supernode. These are described as the real backbone of the Pi blockchain. Their specific job is achieving that SCP consensus, making sure the ledger is correct. They also keep other nodes and supernodes updated with the latest state of the blockchain. But the requirements are higher. You need to be online 24/7, have a really good internet connection, and initially they're selected by the core team. So yeah, this tiered system lets lots of people participate at different levels while making sure the critical tasks are handled by the most reliable folks.
Okay, so if someone listening is thinking, all right, I want to help build this network, I want to be a node or maybe even a super node, what's the actual process? How do they get started?
It's designed to be pretty straightforward, according to the source material. First step, you download and install the Pinode software onto your computer. Then, right inside that software, you fill out the application form. After that, there are some technical packages you need to install. The Node interface guides you through that. And then, basically, you just need to keep the software running. It can just run in the background.
Okay, install, apply, set up, keep it running. Then what? You just wait.
Pretty much. The core team selects nodes and supernodes based on certain criteria, and this happens over a 3-month evaluation period, it seems. If you're selected, you get notified through the node interface. And then, crucially, you have to complete KYC, Know Your Customer verification, to actually operate as a node on the testnet.
And what are those criteria they're looking for? You mentioned supernodes have higher requirements.
Yeah, the bar is higher for supernodes, but the basic criteria are similar. Think about what makes a network reliable. First is uptime, how consistently your machine is online. Ideally, 204/7 for supernodes. So, you can't just turn off your computer whenever you feel like it if you're aiming for that level. Then, a good internet connection, fast and stable. Also, initially at least, being able to open specific ports on your home router, that might be a bit technical for some.
The port forwarding thing. Yeah.
Yeah, exactly. Plus, having enough processing power and memory, the source suggests they provide some guidelines or maybe a table for that. And interestingly, they also look at your previous contributions to the Pi community and the strength of your security circles.
So the social trust element comes back in again, even for node selection.
It seems so. It reinforces that link between the mobile app's social network and the blockchain's infrastructure. It's all part of ensuring the network is both reliable and secure through this vetting.
Okay, vetting makes sense for reliability, but, building a truly decentralized network with potentially millions of users, that's not just about picking the right people, right? It's a massive engineering lift. Especially trying to integrate trust from mobile users in this unique way. How are they actually planning to build this, step by step? Which brings us to the Testnet Roadmap, I guess.
Absolutely. It's a huge undertaking, and they have a phased approach for the testnet. The sources describe 3 main phases. First is the selection phase. This is where the core team runs the consensus algorithm with the node applicants who've got everything installed correctly. The main goal here is just gathering data, understanding the real-world specs needed, like what hardware actually works well, how much uptime can people realistically manage, bandwidth needs, connection stability, all that practical stuff for a reliable network.
Okay, gather data first. What's next?
Phase 2 is the review phase. This is described as an iterative process. Lots of testing scenarios, reviewing how the consensus algorithm performs. And here's a really crucial point. During this phase, the node software's blockchain component will temporarily have a centralized layer.
Whoa, hang on. Centralized layer. In a project all about decentralization, that's going to raise some eyebrows, surely. How do they explain that? What's the justification?
It definitely sounds counterintuitive, I get that, but the sources are quite direct about it. This centralized layer is explained as a temporary tool specifically for efficient stress testing. It lets the core team basically feed simulated network data or configurations to the nodes, so they can run hundreds, maybe thousands of what-if scenarios really quickly.
Like, what if half the network suddenly disconnects? Or tons of nodes join at once?
Exactly, those kinds of things. Things that would take ages to happen organically in the real world. It's like running experiments in a controlled lab instead of waiting for real-world chaos. The sources emphasize this layer will be removed before the mainnet launch. They argue it's necessary to properly adapt and scale SCP for this unique setup. Lots of personal computers, integrating security circles. Testing that complexity without this temporary phase would be incredibly slow.
Okay, so it's a testing tool, not a permanent feature. The risk, I suppose, is making sure everyone understands it's temporary and trusting it will be removed.
Transparency is key there, absolutely. And they seem to be trying by stating it in their docs. Then, the third phase is the live testnet. This is where it gets real. Different node types start doing their jobs using actual data from the mobile user security circles and real network activity. It's still iterative testing, analyzing data, debugging, revising, but now the focus is hitting those targets for security, liveness, scalability under real-world load.
So this whole phased approach, starting controlled and gradually decentralizing, How does that stack up against, say, other blockchains that try to launch fully decentralized right out of the gate? Does it help avoid common pitfalls?
That's a really interesting question. It seems like a more cautious, perhaps pragmatic approach, especially given the scale and the novel integration of the social trust layer.
Mhm.
It allows them to iron out kinks in a more controlled way before opening the floodgates, potentially avoiding some early stability or security issues that purely decentralized launches might face.
Right. Okay, before we wrap this up, let's hit some common questions people might have based on the sources, practical stuff.
Good idea. First one. The connection between the Node program on your computer and the Pi app on your phone. They're complementary, linked to the same single Pi account. You use your mobile app login for the Node software. Right now, it's one node per account. And remember, mobile mining. That only happens on the mobile app. The desktop interface just gives you other functions, checking balance, chat, etc. Running the Node software won't mess with your mobile app functions.
Got it. One account, two interfaces, basically. What about the impact on your computer? If you run this node, is it going to slow everything else down?
It depends on the level. If you're just using the basic desktop app interface, the impact is minimal. Very little CPU, memory, or network usage. But if you're running the full node or supernode functions actually validating the blockchain, then yes, it will use more CPU, memory, storage, and definitely network bandwidth.
Huh.
Pi is apparently using the testnet phase to gather data on exactly how much impact different devices experience so they can give better guidance later.
Okay, so expect some resource usage if you're a full node. And the big one, rewards. Do you get Pi for running a testnet node?
The sources are very clear on this. No. There are no mining rewards specifically for running a testnet node. The whole point of the testnet, including node operation, is to collect data. That data will help them figure out a fair and effective incentive mechanism for nodes once the mainnet is live. So rewards are a future thing, TBD.
Oh, no testnet rewards. Good to know. And what about open source? Is the code available?
The plan is for the blockchain component of the node software to be open source, yes. They mentioned they're organizing a GitHub repository for it, and the idea is to eventually list issues there for the community to help tackle. That's a positive step toward transparency and community involvement.
Okay, so summing up, we've really dug into Pi Network's unique take on decentralization. It's very user-focused with these different layers of participation and this quite methodical testnet roadmap, including that, let's call it controversial, but explained temporarily centralized testing phase. It's definitely a different path they're forging.
It really is a balancing act between making it accessible and keeping it secure and functional.
So, the final thought for you listening. What does all this actually mean? Think about it. How might this unique blend of consensus, progressive decentralization, and user accessibility change the game for what a global digital currency could be? Especially one built fundamentally on human trust relationships mapped onto a blockchain. And maybe consider the long-term implications, the potential upsides,